Assalamualaikum dear students, how are you? I hope you are fine. Let's start maths task. Today we will revise chapter number 3, which is about decimals. As we know that the decimal can be converted into is given us by the rational numbers or a fraction. So here is our task to convert decimal into rational numbers and separate the terminating and non-terminating decimals. Okay, here is the rule how to identify the terminating decimal. The simple rule is that firstly you have to convert the fraction into its lowest term. After this, you will check the denominators of each value. Okay, if there is the in the denominator all the prime factors of the denominator are 2s or 5s or both, but nothing else other than 2 or 5. Okay, then it is called terminating decimal, and otherwise it is non-terminating. Like there is 9 by 7 and in the denominator the 7, it is non-terminating because denominator is 7, not 2 or 5. Similarly 17 by 8, in this fraction the denominator is 8. If we convert it to 8 into its prime factors, we will get 2 multiplied by 2 multiplied by 2. It means all 2's are here in prime factors of 8, so it is a terminating decimal. It is 20 by 6, but firstly we have to convert it into its simplest form or standard form. So you will divide it by 2, you will get 10 by 3. Now and its denominator it is not 3, not 2 or 5, so it is a non-terminating decimal. Okay students, but to clear this concept, I have a video for you so that you will be able to understand how to convert the decimal into fraction and how to convert the fraction into decimal and separate the terminating and non-terminating decimals easily. So let's start the video.
This is one of the most interesting videos based on classification of rational numbers. We know that they are either terminating decimals or non-terminating recurring decimal numbers. We also know that they can be expressed as p divided by q, where q is not equal to 0. But just by looking at a fraction, can you tell if it's terminating or non-terminating recurring? Let's see. We look at 6 rational numbers in the p by q form. 5 by 2, 17 by 5, 8 by 15, 9 by 20, 17 by 6, 11 by 21. Without calculating the value of each in decimal form, can you directly tell the category each of them falls into? This category or this one? Let's make 3 rows and analyze it. Let this be the row of our numbers. Just for our understanding, let us calculate the decimal values of each in this row. And we write the form of each decimal in this row. By form, I mean either this or this. We will write T if it's terminating and NTR if it's non-terminating recurring. Let's try calculating the decimal values of each of the numbers first. 5 by 2 can be written as 2.5, so we can say that it is terminating. The digits after the decimal point end and do not go on forever. 17 by 5 equals 3.4, which is also terminating. 8 by 15 equals 0.53333 and so on. It does not terminate. The digit 3 is repeated indefinitely. So we can say that it's a non-terminating recurring decimal. 9 by 20 equals 0.45, which is terminating. So what we are doing here is calculating the decimal value of all the numbers and classifying it into terminating and non-terminating recurring decimals. Only 2 more numbers remain. 17 by 6 equals 2.83333 and so on. So correct, it gets classified as non-terminating recurring fraction. And 11 by 21 equals 0.523809, 523809 and so on. This part is repeated, so it's a non-terminating recurring fraction. Imagine trying to do all of this without a calculator. That's how your eyes would look, stunned. Don't worry, there's a quicker way. All we need to do is look at the denominator. Yes, even if we just look at the denominator, we can figure out if it's a terminating or non-terminating recurring. The denominator of the first number is 2, and the denominator of the second number is 5. We just need to keep a small thing in mind. We reduce the denominators to its prime factors. The denominator of the third number is 15. In terms of its prime factors, it can be written as 3 times 5. What about 20? It can be written as 2 squared multiplied by 5. 6 can be written as 2 times 3. And 21 can be written as 3 times 7. That's all we had to do. Reduce the denominators to its prime factors. Let's observe the denominators of the terminating decimals. The prime factors of the denominator are either 2 or 5 or both 2 and 5. Now let's look at the prime factors of the denominators of non-terminating recurring decimals. They have numbers other than 2 and 5. Yes, that's the trick. If the prime factors of the denominator are 2 or 5 or both, then the decimal is terminating. If the denominator contains any prime factor other than 2 or 5, then it's a non-terminating recurring decimal. These are the only 2 rules you need to remember. Have you noticed how simple it is to know if the decimal is terminating or non-terminating recurring? All we have to do is write the denominators in terms of its prime factors and apply these rules. Let's generalize these 2 rules. If the number is in the form p by q, then all we need to do is reduce q to its prime factors. For terminating decimals, q will be of the form 2 raised to m multiplied by 5 raised to n, where m and n are integers. It simply means that the prime factors will be either 2 or 5 or both. And how do we generalize q for non-terminating recurring decimals? It's simple. We write it as 2 raised to m multiplied by 5 raised to n multiplied by k, where k is a prime factor other than 2 or 5 and m and n are integers. It can be 3, it can be 7 or 11, whatever. If the denominator contains any prime factor other than 2 or 5, it will be a non-terminating recurring decimal. We have seen that rational numbers comprise of terminating decimals and non-terminating recurring decimals. In this video, we will see how we can convert a decimal number to the rational form p by q. When we are given p by q, we can divide p by q to get a decimal number. But to convert a decimal number into the form p by q is a little more interesting. Let's look at this conversion first. Terminating decimal to the form p by q. So let's look at our first example, 0.45. There's only one thing you need to observe here. It's the digits after the decimal point. In this case, we have 4 and 5. 2 digits after the decimal point. This was the most important step. Once we find this, we write the number without the decimal. In this case, it's 045. We write it without the decimal point and divide it by some power of 10. And what will be the power of this 10 in the denominator? Yes, it will be the number of digits after the decimal point, which is 2 in this case. This is actually 45. So 0.45 can be written as 45 divided by 10 squared, which can be written as 45 by 100. There's our answer. It's in the p by q form. This answer is not incorrect, but it's not complete. We have to reduce it to its simplest form. 5 multiplied by 9 equals 45 and 5 multiplied by 20 equals 100. This equals 9 by 20. This is the answer since it's in the simplest form. 0.45 was written as 9 by 20. All we had to observe was the number of digits after the decimal point. Here's another example, 2.225. It has 3 digits after the decimal point. So first we write the number without the decimal. It will be 2225 and divided by 10 raised to 3. We write 3 as the power of 10 since we have 3 digits after the decimal point. And that will equal 2225 by 1000. And this can be reduced to 89 by 40. So we wrote 2.225 as 89 by 40. That was simple. But what if you're asked to write 2.225 as a mixed fraction? A mixed fraction is something like 3 1 by 4. It means 3 and a quarter. 3 is called the whole part and 1 by 4 is called the fractional part. So how do we get this decimal form in this mixed fraction form? It's very simple. The whole part is the number to the left of the decimal point. 2 becomes the whole part. The numerator of the fractional part is the number to the right of the decimal point. It's 225. And guess what? The denominator of the fractional part is the same as the denominator in the previous case, 10 raised to 3. Again, the power of 10 is equal to the number of digits after the decimal point. That's it. Now we just have to simplify the fractional part to its simplest form. This can be written as 225 by 1000. This is the whole part and this is the fractional part. This, when reduced, gives us 9 by 40. So 2.225 can be written as 2 9 by 40. That becomes a mixed fraction form. Just to check your answer, it's always recommended that you convert this into a normal fraction and verify. This would equal 2 multiplied by 40 plus 9 by 40. That would equal 80 plus 9 by 40, which equals 89 by 40. Same as the answer we got earlier. While converting it into a mixed fraction, just remember that the number to the left of the decimal will be the whole part and the number to the right of the decimal will be the numerator of the fractional part. The denominator in both the cases is the same, 10 raised to the number of digits after the decimal place.
Very good, students. Now it's your task to practice these two exercises of chapter number 3 so that you'll understand it clearly. Okay. Also revise these summaries of all the chapter we have revised in our previous lectures. Okay, students, take care. Allah Hafiz.